Okay, so in the previous lecture I looked at the development of the trophoblast, but in this lecture I'm going to be talking about the development of the embryoblast. First thing that happens to the embryoblast is that it forms the bilaminar disc, which is the epiblast, which goes on to form the trilaminar disc and the embryo, and the hypoblast, which goes on to form the primary yolk sac, secondary yolk sac, and then dies. So as I said, the hypoblast, it migrates and lines the blastocyst cavity on the outside here, and then forms the primary yolk sac, and then the secondary yolk sac, and then degenerates. The epiblast, however, that grows and forms an amniotic cavity in the center here, and then it forms the trilaminar disc. So what's the trilaminar disc? Well, the trilaminar disc is the ectoderm, mesoderm, and the endoderm. Ectoderm goes on to form the skin and nervous system. The mesoderm forms the muscles, heart, and genitals, and the endoderm forms the gastrointestinal tract, lungs, pancreas, and the liver. Formation of the trilaminar disc happens at day 16, and the process is called gastrulation. So you can see that here, epiblast forms the trilaminar disc, forming the ecto, endo, and mesoderms. Now the way gastrulation happens is that, well, you've got the epiblast. What happens is that first the primitive streak forms along the AP axis, and that basically tells you what's the front, what's the back, anterior, posterior body axis. Then the epiblast cells move. The endoderm is on the bottom and it pushes the hypoblast, which, as I said, it lines the cavity. The mesoderm forms between the ecto and endoderms, and the remaining cells at the top, they become the ectoderm. So in gastrulation, day 16, the primitive streak forms, forming the anterior posterior body axis, and at the end of the primary streak, there's a node called Henson's node, which I'll mention in a second. Another thing to note is that in the midline there's also prenotochordal cells, which will go on to form the notochord. So looking at the mesoderm, how does it develop? Well, the mesoderm, it fills in between the ectoderm and the endoderm, as I showed here, except at two places. So the first is the buccopharyngeal membrane, which is the mouth, and the cloacal membrane, which will form the anus. Now the buccopharyngeal membrane is quite important in embryology because it stops the layers from separating and establishes polarity. So the ectoderm, mesoderm, and endoderm, it stops the layers from separating in order for the organs to go to the right place. Now I mentioned Henson's node, and what Henson's node is it's a specialized mesoderm at the end of the primitive streak, which lays down the notochord. So what the notochord from the prenotochordal cells in the midline. The notochord is a dense cord of tissue which will eventually guide the spinal cord. So in terms of what we've talked about so far, you've got the midline created by the primitive streak, forming the anterior posterior axis. You've got the buccopharyngeal membrane and the cloacal membrane. You've got the primitive streak with the Henson's node at the end of it, which laid down the notochord. And I'm going to talk about the cardiogenic area in a second. Interestingly, the cardiogenic area lies above the buccopharyngeal membrane. So therefore the mesoderm has to bend round in order to put the heart and mouth in the right place. So you can see here that, obviously the heart should not be above the mouth. So you know that it needs to bend round at some point to come and put it in the right place.